Welcome to the homework solution tutorial. This is on 3E. I'm going to be covering number 1, A and B here. It asks us to write the quadratic equation vertex and in standard form. We'll start with vertex form. Vertex form requires to grab a vertex. So let's see if we can visually get the vertex from that graph. So we go to the graph. Here's that vertex, which is the maximum here, which is, it looks like that point 2, 1. So here, this is the vertex. So we know that h is equal to 2, k is equal to 1. Let's just write that here. H is equal to 2, k is equal to 1. We now need to know a. So notice, we need to know a. Notice that this is when a is equal to 1, right? So if it opens down, we know that a has to be equal to a negative number. We know it's 1 when it follows 1, 3, 5. Okay, so does this follow 1, 3, 5? 1, 1, 2, 3 across 1. Yep, this does follow 1, 3, 5. So it's this one. Okay, it opens downward and it follows 1, 3, 5. So a is equal to negative 1. Okay, so now you can just write it in vertex form. Vertex form is y equals to a x minus h squared plus k. So y is equal to negative 1 parentheses x minus 2 squared plus 1. All right. If we don't believe that, we can actually graph it on Desmos to double check our work. Okay, so let's do that. Negative 1. So y is equal to negative 1 x minus 2 squared plus 1. Okay, does that work? Yep, that does match up with our graph. So we did it correctly. Okay, now how do we get it into standard form? Well, what we have to do is we can now there's an easier way by looking at the x-intercepts, but I'm going to show you the long way. Okay, so please note, right, that x squared is equal to just x times x. So I'm just going to expand this out. Negative parentheses x minus 2 times x minus 2, add 1. So I'm going to do inside this first. So I'm going to do what's inside the parentheses first, okay? So this is an x squared minus 2x minus 2x plus 4 plus 1, okay? So this simplifies into negative 4x plus 4 plus 1. Okay, all I did was I FOILed here. Now I'm going to distribute that negative. Do you see? This is still inside that parentheses, so I'm now going to distribute that negative over. Negative x squared plus 4x minus 4. Do you see how there's a plus 1 in the end? Plus 1. So negative x squared plus 4x minus 3. We can always graph it to double check. So here's our original. So I'm going to turn that off and I'm going to graph this here. Y equals to negative x squared plus 4x minus 3. Are these the same? Yep, they're the same. So we did it correctly. Okay, this is now in standard form. Okay, great job. Okay, this is in vertex form. This is now in standard form. Okay, let's do it here. All right, well, we know that we need to grab the vertex. So the vertex looks like this is negative 3, negative 5. It opens upwards. So a is equal to positive. Okay. Let's see if it follows 1, 3, 5. Up 1? No, it does not. It goes up 2 across 1. Then it goes how much? 1, 2, 3, 4, 5, 6 across. Oh, 6. So it's going to 2, 6, 10. So a equals to 1 for 1, 3, 5. A equals to 2 when it's 2, 6, 10. So we know that here a is equal to 2 because the way the points are moving, from the vertex to the next point is going up 2 across 1. To the next point, it's going up 6 across 1. So let's write this. A was equal to 2. We have our h here. Our h is equal to -3. And our k here is equal to -5. Okay, we put it in vertex form. Vertex form is a is equal to x minus h squared plus k. So write this in. 2 positive because it's opening upwards. X plus 3 squared minus 5. Okay, if we don't trust our work, we could always double check by graphing it on Desmos. 2 parentheses x plus 3 squared minus 5. Does that work? Let's see. Does it cross where we want it to cross? Yep, perfect. Good. Is that our vertex? 3, 5, and it crossed where it wants to cross. Perfect. So that's how we did it correctly. Good job. Okay. Now we want to put it in standard form. All right. So expand out the exponent. So everything else remains the same, okay? I'm going to write the expanded out in red. So it's x plus 3 times x plus 3 minus 5, okay? I'm going to do on the inside first. So let's do what's on the inside. So x times x, x squared plus 3x plus 3x plus 9 was inside the parentheses, okay? I'm still going to combine what's inside the parentheses, so hang on. So I rewrite everything. X squared, 3x plus 3x is 6x plus 9. Close the parentheses. Then you have a minus 5 here. Okay. I'm just foiling here or just distributing. Now I can distribute that 2 in. Okay. Do you see that 2? It's going to be distributed in. Do not subtract the 5. That 2 is still in front. So it's 2x squared plus 12x plus 18. Now you have that minus 5. So it should be y equals to 2x squared plus 12x plus 13. All right, now let's take a look at the graph. Okay, so that was our original. All right, and our new one needs to look exactly the same. So y equals to 2x squared plus 12x plus 13. Yep, do you see how it's identical? The red and the green overlap. That's mean they're identical equations. So that's how we know we did it correctly. So there you go. That is how you do number 1. How to convert it from writing vertex and standard form from a graph.